Okay, we're going to be looking at completing the square as a way of solving quadratic equations. So let's begin by considering two expressions. Let's think x plus d squared, and let's think x minus d squared. Now if we expand these out, we get these results. And x minus d squared equals x squared minus 2dx plus d squared. Now we can rearrange this to give us x squared plus 2dx equals x plus d squared minus d squared, and x squared minus 2dx equals x minus d squared minus d squared. Now this and this are both quadratic expressions, and this is a solution for them. Let's look at a few very simple examples to see what we mean, and then I'll show you how this can be used quite powerfully to solve more complicated quadratic equations. So let's think x squared plus 10x. Well, that is similar to this. The 2d, 10 equals 2d, where d would be 5. 10 divided by 2 equals 5. So we can factorise this as being x squared plus 10x equals x plus 5 squared minus, now d is 5, so d squared is 25. And that's the factorisation of this expression. Let's think of another one. Let's think of x squared plus 8x minus 7. So here, we're just going to ignore this minus 7 for now. Let's look at the coefficient of x. 8 divided by 2 equals 4. So this is x squared plus 8x minus 7 is going to be x plus 4 squared minus 16 plus 4 squared, 16 minus 7. We'll just collect those terms. Is going to be minus 23. Okay, we're going to look at another example which is a bit more challenging. So we're going to look at this expression: 2x squared minus 12x plus 5. Now to do this we're going to rearrange this a little bit. We're going to take factor of 2 out, and we'll have x squared minus 6x plus 5. Now the part inside the square bracket we can now factorise using completing the square. So with x, this one's a minus this time, not a plus, so minus half of 6 is 3 squared. 3 squared is going to be minus 9 plus 5. So it's going to be 2x minus 3 squared. Now this 2 has to still be multiplied by the minus 9, so it will be minus 18 plus 5, which is 2x minus 3 squared, which is minus 13. And there we go. We can also use an algebraic term method for solving quadratic equations through completing the square, and I'll show you what we mean by that. So let's have expression 2x squared minus 12x plus 3 this time, and we want to put it in the form, p x minus q squared plus r, where p, q and r are constants to be found. So let's take this and set it equal to this. Now the first thing is we're going to expand this expression out. So we're going to have p, and it's going to be x squared minus 2qx plus x squared plus r, which is going to give us px squared minus 2pqx plus pq squared plus r. Now that is all equal to the 2x squared minus 12x plus 3, or 4 with x here. Now we're going to compare terms. So here the x squared coefficient has got p. The x squared coefficient here is 2, so p must be equal to 2. Here we've got the x term, which has 2pq on this side. It must be equal to 12. We know that p is 2, so 2 times 2 times q equals 12, so q must be equal to, that's 4, 12 divided by 4 is going to be 3. And here we have the constant term at the back, 3. 3 must be equal to this, p q squared plus r. Now we know that p and q are 2 and 3, so we've got 2 times 3 squared, which is 9, plus r, so that's 18 plus r, so r must be minus 15. So this must therefore equal p is 2, x minus q, which is 3, squared minus 15. I'll do one more example of completing the square. So let's do 5 over x plus 2 plus 3 over x minus 5, sorry, not 3. Equals 1. So first we're going to multiply both sides by x plus 2, x minus 5. So it's going to give us 5, x minus 5 plus 3, x plus 2 equal x plus 2, x minus 5. Now we're going to multiply out the brackets and collect our terms again. 5x minus 25 plus 3x plus 6, and that's x squared plus 2x minus 2x um, 5x minus 10. As at this stage, it's your risk of when you collect the terms and you're moving things from one side to the other, where you can get in a pickle with your signs and your arithmetic. So let's gather terms together. So we've got x squared here, plus 2 plus minus 5 is going to be minus 3x minus 10, and we have this minus 5x here, plus 25 minus 3x minus 6 equals 0. Let's gather the rest of the terms together. So the x minus 3 minus 5 minus 5 is going to be x squared minus 11, x, then we've got minus 10 plus 25, which is going to be 15, minus 6, which is going to be plus 9 equals 0. Now we're going to use completing the square. So we're going to have x minus 11 over 2 squared minus 11 over 2 squared plus 9 equals 0. Now if we do our arithmetic, we're going to have x minus 11 over 2 squared equals square root of 85 over 4 over, jumped ahead, it's going to be 85 over 4. Now we want to solve this, so this is where we square root the other side, so it's x minus 11 over 2. It's going to be plus or minus because we're taking the square root, and we can have a positive or a negative solution. Square root of 85 over 4. So x is going to be 11 over 2 plus or minus square root of 85 over 4. Now the square root of 4 is 2, so what we can do here is we can have 11, we can take half out and have 11 plus or minus the square root of 85. Now you would leave it in this form because you're going to get some horrible big decimal if you solve it. This is a more elegant way to put the solution. So I hope that